today we're doing algebraic operations with vectors. What we're doing today, we will also do tomorrow. So, problem number 1, it says draw vector V, and vector V goes from point A to B, where point A is at 4, 7, and point B is at negative 4, 3. So that's the first thing we need to do, is go ahead and plot those 2 points. So point A is at 4, 7, and point B is at negative 4, 3. Now this is a vector, so I do have to have an initial point as well as the terminal point where I place the arrow. Now the initial point is going to be whatever point is listed first. So notice right here in the vector format, the first point is A. So A is the initial point. That means B is the terminal point, and we'll get the arrow, and then I need to connect those 2 points. So there's my vector AB. Now the next thing on our to-do list, it says to draw a vector equal to vector V. Now we learned on Monday 2 vectors are equal if they have the same magnitude as well as the same direction. And what does magnitude mean? Length. So I need to draw another vector that has the same length and it's going the same direction. And then it goes on to say that the initial point has to be at the origin. So my initial point was over here at 4, 7. Now I'm moving it to the origin. So let me label this one. This one was vector V. So now the initial point is no longer at 4, 7. It moved to the origin. Now we also need to move point B. So to do that and to ensure we're moving the same direction, starting at point A, I need to figure out how many units do we go to the left and how many units do we go down to get to point B. So how many units do we go to the left? 8. And how many units do we go down? 4. So from the origin, go left 8, down 4, and there is our vector that's equal to vector AB. Now notice that vector, its initial point is at the origin. That vector is called component form. And the definition is the vector is positioned at the origin is called the component form of vector V. So this guy right here, that's the component form. So component form just means the initial point is at the origin. And that's the component form of vector V. Now, there's a certain notation we use for component form. For component form, it looks like an ordered pair. We still place the points x, comma, y. So x is first, y is second for those 2 blanks. But notice it's not parentheses. Notice we have these angled brackets. So for component form, we just use angled brackets and not parentheses. Now, where does this ordered pair come from? That comes from your terminal point. So looking right here, let me put it in black. Here is my terminal point right here. What is the x value for that point? The x value, negative 8. And what's the y value? Negative 4. So there's the component form. The component form, we use angled brackets, and the point that we use is the terminal point. We don't ever use the initial point because the initial point is going to be the same for every vector that's in component form. The initial point is always the origin. So we never report the initial point because it's known to be the origin if it's in component form. So for component form, it's always the terminal point that's used. And then we do have a formula. The component form of vector V is a vector equal to V whose initial point is at the origin. So for component form, if you're given 2 points, and we are right here, here is x1, here is y1, here is x2, here is y2. So according to the formula, to find the x value, it's just x2 minus x1. To find the y value, it's y2 minus y1. So let's check it and make sure the formula works. So for x2 is negative 4. Subtract x1, and what's the value for x1? 4. And what's negative 4 minus 4? Negative 8. Now for the y values, the y2 value is 3 minus the y1 value is 7, and 3 minus 7 is negative 4. So notice the component form formula does work. Next example. Problem number 2, we're given point 8. Point A is at negative 8, 3, and point B is at negative 2, negative 5. We need to find vector AB in component form. So we're going to do this geometrically. So we need to graph those 2 points. So graphing the point, point A is at negative 8, 3. And point B is at negative 2, negative 5. Now again, with vectors, the first value listed, or not the first value, the first letter listed is your initial point. So the initial point is A, the terminal point is B. Now, to find the component form, that means the initial point has to be moved to the origin. So the point that's at A needs to be moved to the origin. To keep the vectors going the same direction, I need to figure out how many units do I go down, how many units do I go to the right. So how many units do we go down? 8. How many do we go to the right? 6. So from the origin, I need to go down 8, right 6, and there's my component form. Now, I actually didn't find the component form. So to actually find the component form, our component form has the angled brackets, and then we write our ordered pair of the terminal point. So looking at that red vector, here's the terminal point, and what is that x value? The x value is 6. The y value is negative 8. So 6, negative 8 is the component form. Make sure you're using the angled brackets for component form. And then part B. What do those vertical bars mean? It's not absolute value. What is it? Magnitude. So we need to find the magnitude of vector AB. Well, what does magnitude mean? Length. Well, we could look at this right triangle. This would be a 6, 8, 10. That's a Pythagorean triple, right? So technically it's 10. But on Monday we learned a formula. Remember our formula to find the magnitude? It's the square root of x squared plus y squared. So the x value is 6, so that would be 6 squared, plus the y value is 8, so that would be 8 squared. 6 squared is 36. 8 squared is 64. 36 plus 64 is 100. Square root of 100 is 10. So we found the answer 2 different ways. We looked and we saw the right triangle with a Pythagorean triple, or we used the formula. It's the square root of x squared plus y squared. Now that one came out nicely. We had a perfect square. But if you didn't, then you would need to simplify your radical. Problem 3, we need to perform the following operation both graphically and algebraically. So Number 3, we're given vector u is negative 5, 2, and vector v is negative 3, negative 6. Now notice both of these are in component form because of the angled bracket. So that means both of those have an initial point at the origin. So let me go ahead and plot those two vectors in component form. So vector u, again, the initial point is at the origin because it's in component form. And the terminal point is at negative 5, 2. And this is vector u. Vector v is also in component form, so its initial point is also at the origin, and its terminal point is at negative 3, negative 6. Now, what we're about to do is going to be what we did on Monday when we constructed these vectors, not algebraically, when we constructed these vectors geometrically. So notice for our problem, we have two different vectors. So on Monday, I told you if you have more than one vector, always go left to right. So start with vector v. So now I'm going to switch to black. So vector v is where we're starting from. And then after I plot vector v, I need to subtract 2 vector u. And on Monday, we talked about the subtraction. What does the subtraction mean? You change direction. So for vector v, here's vector, not vector v. Yeah, vector u is what we're after. We already took care of vector v. So for vector u, we go left 5, up 2. So if I have negative vector u, I change the direction. So instead of going left 5, I need to go right 5. And instead of going up 2, I need to go down 2. So remember, this is tip to tail. So wherever we just left off, that's our new starting point. So right here is where we left off. So from this point, I need to go right 5, down 2. And then I'm going to label that. That is negative vector u. So how many negative vector u's do I want? 2. So I need to do that one more time. So from that point where I just left off, I need to go right 5, down 2. And on Monday, after we followed all of the steps, we were looking for the resultant force. So we need to draw in the resultant force. And the resultant force is always from the first tail to the last tip. And now we're going to write our answer in component form. So put your angled brackets. And it's always the terminal point that we're after. So the terminal point is right here. And what is the x value for that point? If I follow it up to the x-axis, it's 7. And the y value is negative 10. So 7, negative 10 is our component form. Now that's geometrically. Now to do it algebraically, it's a lot easier, it's a lot faster. So algebraically, again, algebraically we go left to right. So notice it starts with vector v. So we're going to use the component forms. So vector v, its component form is negative 3, negative 6. And then after vector v, what do you see? Minus 2. And after the minus 2, what do you see? Vector u. So for vector u, put the component form. So for vector u, it's negative 5, 2. And from here forward, it's essentially just PEMDAS. So what do you think I would do next? Yeah, here we need to distribute the 2. We're only going to distribute the 2. We're going to keep the subtraction. So bring down the subtraction and distribute the 2. So what's 2 times negative 5? Negative 10. And what's 2 times 2? 4. Now, when you subtract two vectors, you subtract the x's, you subtract the y's. And that's when they're in component form. So when I subtract the x's, this would be negative 3 minus negative 10. And when I subtract the y, it's going to be negative 6 minus 4. Now, I'll just write it out this first time so you can see what's happening. So it's negative 3 minus negative 10. Same thing for the y's. Negative 6 minus 4. And when I subtract a negative, that changes to addition. So 10 minus 3 is 7, and negative 6 minus 4, negative 10. So there's our component form algebraically. And how does it compare to geometrically? It's the same. So you should get the correct or the same answer either way. Okay, more practice with algebraic operations. It says perform the following operations algebraically. So again, this only works if they're in component form. So we have vector u plus vector v. So what do I put for vector u? 6, negative 4. We need to add to that vector v. So what's vector v? Negative 5, 5. Now, addition is just like the subtraction. Add the x's, add the y's. So for the x's, what's 6 plus negative 5? For the y's, what's negative 4 plus 5? So that first answer is 1, 1. Don't forget the angled brackets. Part B, we have vector u minus vector v. So vector u is first. So for vector u, it's 6, negative 4. We need to subtract vector v, which is negative 5, 5. Now, make sure the x's are both subtracted. Make sure the y's are both subtracted. So for the x's, I'm not going to write it out, but what is 6 minus negative 5? 11. Same thing for the y's. What's negative 4 minus 5? Negative 9. So 11, negative 9 in component form. Problem C, we have 3 times vector u plus 1/2 times vector v. Again, left to right. So the 3 goes first. And then we have vector u, and vector u is 6, negative 4, plus 1/2. Now we have vector v. What do I put for vector v? Negative 5, 5. Now again, PEMDAS, take care of your distributing. So distribute the 3. What's 3 times 6? 3 times negative 4. Bring down the plus sign. Distribute the 1/2. What's half of negative 5? Negative 2.5. And what's half of positive 5? Positive 2.5. Now when you're adding component forms, add the x's, add the y's. So for the x's, what's 18 plus negative 2.5? 15.5. And for the y's, what's negative 12 plus negative 2.5? Negative 9.5. So 15.5, negative 9.5. So be careful with your signs. And then the last one for this page, we have negative vector u. So that just means negative 1 times vector u. So we'll have the negative first, and then vector u is 6, negative 4. Distribute that negative, and what would the component form be? Yeah, -6, +4. Now for part E, we already did vector u plus vector v. That was right here. For vector u plus vector v, what did we get? 1, 1. So we're not going to redo it. But part F, what do those bars mean? Magnitude. So we need to find the magnitude of vector u and add to that the magnitude of vector v. What was the magnitude formula? Square root of x squared plus y squared. Now, remember component form, it's just like an ordered pair. This is x, this is y, this is x, this is y. So let's start with the magnitude of vector u. What is the x value for vector u? So this would be 6 squared. What is the y value for vector u? So -4 needs to be squared. Now moving on to the magnitude for vector v. What is the x value for vector v? So -5 needs to be squared. Add to that the square of y, and what's the y value for vector v? +5 needs to be squared. Simplifying that, 6 squared is 36, -4 squared is +16, so 36 plus 16, 52. -5 squared is, so 25 plus 25 would be 50. Are these like radicals? No, but should I leave that as my answer? No. If a radical can simplify, make sure you simplify it. So what's the perfect square for 52? 4 times 6 times 4 is 24, it's not 16. 13. So how would I rewrite that? 2 square root of 13. And what's the perfect square for 50? 25 times 2, so that would be 5 square root of 2. Now are they like radicals? No, so that's as simplified as I can get it. So don't leave radicals unsimplified. Make sure they're simplified completely. And then the next question, we need to explain how E and F are different. Well, E, what is problem E asking for? It's the vector. The problem E is it's a special vector. What is it? Problem E is the component form of the resultant vector. Problem F is that dealing with vectors? It's dealing with magnitude. So problem F is the sum of the individual magnitudes. So problem E is just the resultant vector. Problem F is the sum of the magnitudes of the individual vectors. Last section. Hit the wrong button. Uh-oh. Here we go. Okay, problem 5. It says vector U is going from point A to point B, where point A is 8, 7, and B is 11, 3. Vector V goes from point C to point D, where point C is 6, negative 4, and point D is negative 10, negative 5. We need to find the resultant vector algebraically. So here we need to do some more vector operations. But vector operations only happen if you have component form. Are we given component form here? How do you know that's not component form? Yeah, we don't have those angled brackets. So the first thing we need to do is find the component form, which takes us back to the very beginning. And this formula in the middle of your page, there's the formula we need to use to find the component form. So to find the component form, it's the difference of the x's, the difference of the y's from the two ordered pairs we're given. So we need to use points A and B. And I'm going to go ahead and label them x1, y1, and x2, y2. And I'll do the work down here. So for vector U, the component form is going to be x2 minus x1, y2 minus y1. What is the x2 value? So this would be 11 minus, what is x1? 8. What is y2? 3 minus, what is y1? 7. So the component form, what's 11 minus 8? 3. And 3 minus 7? Negative 4. So there's the component form we need to use. That one's 3, negative 4. Now we need to do the same thing for vector V. I want you to go ahead and do the same thing for vector V, and then I want you to finish those last two questions. So do part A and part B. So find the component form for vector V, and then answer questions A and B. Okay, x2 is negative 10, minus x1 is 6, y2 is negative 5, minus y1 is negative 4. So what's negative 10 minus 6? Negative 16. And when I subtract a negative, this changes to addition. So it's negative 5 plus 4, negative 1. So there's the component form for vector v, negative 16, negative 1. So now that we have component form, now we're ready to do those algebraic operations. So for part A, it's just negative vector v. So we'll have negative, and then vector v, the one we just found was negative 16, negative 1. Distribute the negative. What's the answer? 16, 1. And then part B, we have vector u. So start with vector u, which is 3, negative 4, minus 2. Vector v is negative 16, negative 1. Distribute your 2. So this would be 3, negative 4. Bring down the minus. Distributing the 2, 2 times negative 16 is negative 32. 2 times negative 1 is negative 2. Now make sure the x's are subtracted and also the y's are subtracted as well. So when we subtract the x's, be careful. What is 3 minus negative 32? 35 is correct. With the y's, what is negative 4 minus negative 2? Negative 2. So our answer is 35, negative 2. Now again, we're doing the same thing again tomorrow. But that's all for today.